Hi everyone, I'm just going to go through a quick video here on the techniques of differentiation. So I'm going to go through just this revision session really. So hopefully now 10-15 minutes I'm going to do algebraic functions, trigonometric functions, and then the exponential and natural log function, okay? And so away we go. This is revision. And hopefully now this will be of great benefit to you, okay? So away we go. First one here now is 4x cubed. You can see it there. So to differentiate that then, just following the basic rule there, multiply down by the power, 12x squared minus 6x plus 6, okay? Multiply down by the power and reduce the power by 1, okay? Over here then, 1/3 multiplied down by 3. 3 by 1/3 is 1. So that's x squared minus 4x plus 3. Hopefully now, yeah, you've no problem with these. These are straightforward. That's 7. You're kind of using the chain rule here in fast forward, if you like. Okay, that's not going to work. Scroll down here now. Yeah, so that there is, okay, 2 minus 3x, reduce the power by 1 to the power of 6. And then with the chain rule, you multiply by the derivative of what's inside, which is going to be minus 6x. Like in terms of the chain rule, this term here would be the du dx at the end, at the back of it, okay, at the end of that formula for chain rule. Right, so I'll take that away now, and then you can tidy that up, simplify that to 42x into 2 minus 3x to the power of 6. Okay, on we go. That then is to the power of a half. Set it up that way. First of all, the derivative multiplied down by the power, reduce power by 1. That's a minus a half there. Now, when you tidy that up, right, that half is going to come down to become a plus half. So it's 1/2 root x. Okay, hopefully now you can see all this and it's coming out okay. That there is an equals. So 1/2 root x is the answer to that one. Now moving down, same idea here now, but that will be x squared minus 2x all to the power of a half again. Now that okay, the derivative then down here, a half, x squared minus 2x to the power of minus a half. Again, you multiply by the derivative of what's inside. That should give you 2x minus 2. Now, the 2 there actually now is underneath the line there, okay? See that 2 there? So that will cancel, that will divide in here, and you would get x minus 1 on top. Can I just change colors there now for a minute? And all of this here, right, all of that there then will go underneath the line and become x squared minus 2x to the power of plus a half, which is effectively a square root. So now, students ask me all the time, do you have to do that? Well, it would be nice if you did that, just to, you know, that looks so much better than the way it is up here, you know. And also you may have to sub in something here, or you may have to let that equal to 0 or a half or something if it's involved in the applications of differentiation. So it's the best thing to do. The best policy is to try and tidy it up if you can. Right now here, same idea, set it up for differentiation, minus 2 plus 2x to the power of a half. Okay, and away we go again then. Minus 2x to the power of, be careful here now, lots of students make this mistake. It's minus, you go down 1, it's minus 3, okay? And then it's, you multiply 2 by the half, you get 1, and take away 1 minus a half again. So again, following my own advice now that I gave earlier, I have to tidy this up. And that's 1/root x. Okay, just make that nicer there. There we have it there. Minus 2 over x cubed plus 1 over the square root of x. On to the next one. These are the last two now in algebra. Again, you set that up there like that. 2 minus 3x to the power of minus 1. Okay, so these functions come up a lot in the applications of differentiation. You could be asked with this function here, prove that this function has no turning points and no points of inflection. You remember that? Yes. Just say yes, or I remember that, yeah. Okay, that's minus 2 there. Multiply by the derivative of what's inside. Now, that minus 1 and the minus 3 will give you a plus 3. And that all goes back down underneath 3x to the power of plus 2. Again, just to go through that again, all of that term there will all go back underneath the line and change from a minus 2 to a plus 2. Likewise here, we set this up as 2 minus 3x to the power of minus 2. Now the derivative, minus 2, 2 minus 3x to the power of minus 3, multiplied by minus 3. And again, it's 6. That's a positive 6 on top, over 2 minus 3x to the power of 3. Very nice, okay? And we move down here then onto the next section then, trigonometric functions, okay? Now the fun begins, lads, okay? Now sine x then goes to, as everybody knows, cos x. You were just about to say that. And 3 sine x will go to 3 cos x. Right, sine 2x will go to cos 2x. So again, we're using the chain rule here now again, really, because I mean, that there is, you would be just in the chain rule, you would be letting that equal to u. And then you would be applying that little formula for the chain rule, dy du multiplied by du dx, okay? So then you'll be multiplying by the derivative of that, which would be 2. Now, usually you would put that 2 in front just to avoid any confusion there. That doesn't look, cos 2x by 2, that doesn't look right. It's 2 cos 2x, that's okay. Then now sine minus sine 3x, well, okay, you could actually say keep the minus because that's actually a minus 1 in front. So keep that if you like. And then sine goes to cos. It goes to cos 3x by 3. And then that's minus 3 cos 3x. Okay, hopefully you can see all that now. And minus 3 cos 3x. Okay. Now, a half sine 4x, okay, with these ones, then you always keep the number in front. That's a half. Keep that in front. That's the constant in front. Sine 4x would go to cos 4x multiplied by 4. And that half, again, that half is underneath. So that's going to cancel with the 4. Yeah, cancel with the 4, and you're going to get 2. 2 into 4 goes 2 times 2 cos 4x. Now, cos goes to, yes, correct. If you said it, sine x. Okay, I'm talking now to an imaginary audience here. Cos x goes to minus sine x. So again, keep that minus 3. Now, cos of 2x goes to minus sine 2x multiplied by the 2. Don't forget, that is a function within a function. It's not x anymore, it's 2x. So got to multiply by the derivative of 2x. And that is minus, that's 2 there. So then what's all that going to give us? There's 2 minuses there. That's giving us 6 sine 2x. Cos of that then will go to minus the sine of 2x plus 1. Oh yeah, multiplied by 2. So again, minus 2 times the sine of 2x plus 1. Okay. I have these. I'll print these out and I'll give you these in grinds anyway, and you can go through them again yourself. That 4. Okay, keep the 4. Now, what's cos going to do? It's going to go to minus the sine of the very same thing, whatever it is. It doesn't matter what it is. It's going to go to that minus the sine of that, multiplied by the derivative of what's inside, which is 3. Minus 12 times the sine of 3x minus pi over 2. Strange looking one there now. This one now is from a past paper, was it, I know, 2016, I think, right? Now, the 1.6 will go to 0 because it's a constant, and the derivative of a constant is 0, okay? And now, then you keep that 1.5 in front of the cos, and again, the cos goes to minus the sine of pi over 6 pi. It's minus the sine of that multiplied by the derivative of what's inside. So what is the derivative of this, of pi over 6 by t? It is actually pi over 6. It's the number in front of the t. So 1.5 and 6, that goes in 4 times. Yeah, so that would be pi over 4 minus pi over 4, I guess, sine pi over 6 t. Okay, just to tidy that a little bit there now as well. Now there it is there, minus pi over 4. Okay, so now these ones are interesting. Haven't seen these in a leaving cert, but they're there. They're on the course. So look, sine squared x is the sine of x to be squared. That's exactly the same thing. I'm just presenting it in a different format there. So I mean, amazing the number of students who don't know that sine squared x is the same as sine x to be squared. Okay, same thing. And then follow the chain rule then again. 2 times the sine of x to the power of 1 multiplied by the derivative of that, which is the cos of x, and then 2 sine x cos x. Now, does anybody know what that is in the world of trigonometry? You don't have to know. Well, it used to be on a lot, it came up a lot in the old course. This particular identity, a world famous identity, lads. A world famous identity, sine 2x. That's not differentiation now. That's just a bit of trigonometry at the end, which I couldn't resist. Okay, I had to put that in there. Now, cos cubed x, cos x, all to be cubed. Right, derivative 3. Cos squared x multiplied by the derivative of the cos x minus sine x. That's it. So that's going to be minus 3. I put the sine x first. I don't know why I just do. That's what I do. It doesn't matter. You can put the cos squared first, but minus 3 sine x cos squared x. Lovely. Again, now this one here then, sine, that's sine x all to be cubed. So that's going to go to 3 sine x all to be squared, which is the same as the sine squared x. And that's sine x then goes to cos x. Yes. So then that then is 3. And now this one then was an exam as well. V and T, probably voltage and time. Yeah. So it's going to be 3, keep the 3. Sine goes to cos 10 pi t. Okay. The cos of 10 pi t multiplied by the derivative of that, which is 10 pi. 30 pi into cos 10 pi t. You could do the bracket around that if you want, but I mean, that's all. I mean, the cos of 10 pi t, that's all one function there. Okay. Now, moving on now, how we fix there. Very good. Now, tan x, right? From the log tables, tan x goes to sec squared x. Haven't seen that yet in project maths. I have not seen it. The tan of 2x will go to sec squared 2x, but again, there's a 2 there. So it's 2 sec squared 2x. 4 tan, keep the 4. The tan of x over 2 goes to sec squared x over 2 multiplied by, what's the derivative of this one? It's a half, okay? So the half then and the 4 will give you 2, got outside the line here, 2 sec squared x over 2. 2 sec squared x over 2. Now, this came up a long time ago, and it could come up again. Why not? Okay, history repeats itself, especially in project maths. All the old greatest hits are coming out again, lads. I was telling you this. Now that there, tan cubed, well then just bring it down then. It's 3 tan squared x. Okay, 3 tan squared x multiplied by the derivative then of tan x, which is sec squared x. So there you have it. And that 3 and the 1/3, they multiply each other, you just get 1. So you get tan squared x sec squared x. I mean, I could have wrote this down as 1/3. And I mean, what is that? It's tan x all to be cubed there, really. And the 3 comes down then and becomes 3 tan x all to be squared. Okay, now this one here now, the derivative of inverse trigonometric functions, that's straight out of the revision book, which you all have. And then you've got the log tables. That's what they give you in the log tables, these two here. That's what's given in the log tables. Oh yeah, you can highlight there. That's what they give you in the log tables. And likewise here, they're the two that are on, sine inverse and tan inverse. Cos inverse is not on. And that's what they do. They give you x over a, so you can just follow this rule. If it occurs, if it comes up in that form, you can just follow the rule blindly. But if it doesn't, if there's any change, you're going to have to establish what the general rule is and then apply that. So this could cause problems. And you know, stuff like this then is what comes up in the pre, and it's just it's just annoying, more annoying than difficult, really, you know. So now look at this one here, tan inverse x over 2. Well, you have it, it's in that form, it's ready to go. Okay, it's ready to roll. So what have you got? The tan inverse, you just go, well, that there then is, oh, actually, no, hang on a second now. That should be an A there. That should be an A there. Sorry there now. That there is an A. I'm not, okay. So that's going to be, so, I mean, this is your tan inverse x over a, right? I mean, the a is 2. So the final answer then is 2 over x squared plus 2 squared, which is 4. That's it. Okay. Now, what I meant to do here was, let me see now. Hold it. Now, what I meant to do here was say y is equal to tan inverse, not x over 2, but 2 over x. This is what I'm talking about now. If they change the format of this, see, you'll be in trouble because the log tables can't help you now. That's tan inverse. That's 2x to the minus 1. So now we have to follow the general rule, which I put together up here. There's the general rule. When you let a equal to 1, you just find out what happens to x, and that's the general rule. That's what we have to apply now down here. We have to apply that. So we're going to get now. So dy dx. What happens to x? It's 1 over x squared plus 1. So this will be 1 over 2x to the minus 1 squared plus 1. Okay? Multiplied by the derivative of this one. And the derivative of this one is minus 2x to the minus 2. Okay, and okay, kind of might run out of space here now, but on top, you're going to have a minus 2. That minus 2 will multiply to 1, but all of this then will go back down underneath, and you'll end up, you'll have it, you'll be multiplying in by that underneath. and it'll be x, oh, sorry, when you bring it up, when you bring it back down, it'll be x squared. When this goes back underneath the line, it becomes x squared into 2x to the minus 2 plus 1. And maybe I should just, yeah, and now go like that. Okay, that's it then. And can I get the answer here then? Minus 2 then over, multiply in there, that's a minus 2 there. So that's going to give you 2 times. Now, x to the power of 2 multiplied by x to the power of minus 2 is x to the power of 0, which is just 1 plus, and then multiplying by that, and there's an x squared there. Okay. Minus 2x to the power of minus 2, yes, and that will stay on top. That goes back underneath. It's going to multiply into this. Oh, but that was already squared. Oh, sorry here now. Sorry. Okay, hang on a second now. I should have given myself more space here now. Okay, so that there then we could just okay, so it's minus 2 on top, and then bring that back down underneath. That's x squared. Now we could do this out first of all. That should be, I should have multiplied that out first of all. So that should be already 4x to the minus 2 plus 1. Now multiply in, and I've got minus 2, and then multiply in, and you're going to get 4 plus x squared. So you have to square that out first of all, 4x to the minus 2, and then multiplying by this. Yes, that's good now. Good. Okay. I probably need a bit more space there now for that one. Likewise with this one here now, this thing is ready to go because you have it in the format you need it. And you see it up there, highlighted in yellow. If it's x over a, it's 1 over square root a squared minus x squared. So it's 1 over square root a squared minus x squared. Okay. So then, yeah, this one then is the sine inverse of 3x to the minus 1. Same idea, we have to set it up like that. We have to look at the general rule to see what happens. It's 1 over 1 minus x squared. So this then will be 1 over, sorry, the square root of 1 minus x squared. So it's going to be 3x to the minus 1 to be squared. Then, but then you're multiplying by the derivative of this one, which is minus 3x to the minus 2. And same thing again then. You have a minus 3 on top. And the x squared comes back down. That goes there into, and then you have to manipulate this. You have to tidy this up here. That there is 1 minus 9x to the power of minus 2. So hopefully it's okay like that, that you will get full marks there. There is more. You could go a step further, but we'll just leave it for that, like that for now. Okay. That now, they're kind of 2 obscure ones, but they could come up. So I can't do this without leaving them out. You know what I mean? So on to the next section there. I mean, I go over them again now in the grinds. Okay. Now here we go. This is the last page now, lads. So bear with us. Okay. 5 minutes left now. E to the x is e to the x. Nice one. E to the 2x goes to, well, e to the 2x by 2. Okay, that's the chain rule again. E, so keep the 3 in front. E to the minus 3x multiplied by the, what's the derivative of this one? Minus 3. So that gives you minus 9 e to the minus 3x. Okay, which, by the way, is just minus 9 multiplied by y. Okay, you may see that sometimes, like that there is y. So there it is there. Y, no, y is 3. Oh, no. So that's wrong there now. Sorry, what I said there now was wrong. It's actually minus, it's minus 3 times y, isn't it? Change that there. Okay. minus 3 times y. Okay. I shouldn't have said that now. I just complicated it there. Don't worry about that. Next one here then is e to the minus a half x squared. Right. Well, then that's going to go to minus a half x squared again. Back to the same thing. And the rule is multiply by the derivative of this. The derivative of that, which is minus x. Yeah. Bring down the minus 2. It's going to count 2 by a half, 1. The minus stays, drop the power by 1. There you have it there. That's come up in a previous exam. This one here then, keep the 100. E to the goes right back to the same thing, but you're multiplying now by the derivative of the power, which is minus 0.05. Okay, and when you multiply 100 by 0.05, what do you get? You actually get minus 5. Okay, so there's your answer, minus 5 e to the minus 0.05x. Now, next one, keep the half e to the minus x squared multiplied by minus 2x, the derivative of the power. And the 2, again, that 2 is underneath. It'll cancel with that one, and you end up with minus x e to the minus x squared. Okay, they're all the e's. Then we're down to the ln's then. ln's then. ln of x is, yes, 1 over x. Very good. And then 2x plus 1 multiplied by 2. That 2 is going to be on top. That again, 1 over it. 1 over, no matter what it is, it's 1 over it multiplied by 2x. So I mean, like, ultimately that 2x will just end up here on top, won't it? Keep that 2, 1 over 3 minus 2x multiplied by minus 2, minus 4. Right? They're all fairly straightforward. So let's put in something down here then. The ln of cos x then, follow the rule, 1 over cos x. And what's cos x get to, what's the derivative of cos x? Minus sine x, okay? So I just put that in there. I put minus sine x in there. Now, what is that then? That is, back to my old trigonometry again. I know I'm annoying you now, lads, with the trigonometry, but I have to do it. Look at it there. What's the story there? What is that when he's at home? What do you call him when he's at home? Yes, tan x. All right, next one then. Okay, that then, well, there's a couple of ways of doing this now. Well, okay, 1 over root x multiplied by the derivative of root x, which is the derivative of root x, x to the power of a half, will go to a half x to the power of minus a half, which is effectively 1 over 2 root x. So you're actually multiplying this by 1 over 2 root x, and that's 1 over 2x. But you could do that in an easier way. You could do that using the rules of logs, which would be much easier if you did that. So you would use the, you could see I just do one of these then. All right. Oh yeah, these are from the revision booklet. So this again hasn't come up for a while. So these are the properties of logs. You have these, they're in the log, they're in the log tables. They'd want to be in the log tables, the property of logs. This one here now, the ln of that. So I'm talking about differentiating expressions, functions that are log functions, okay? So the ln of this thing here inside, that's two functions multiplying each other. So that's the ln of that with a plus in the middle. So we're talking about this rule here, right? Just applying it backwards. And we put a plus there, and then we apply, then we just differentiate then 1 over x squared multiplied by the derivative of that 2x. The x will cancel the x underneath, you get 2 over x. And then sine, 1 over sine, and sine goes to cos. So cos over sine is cotan. It's tan is sine over cos. So cos over sine is the inverse of that. So it's 1 over tan, which is cotan, right? bit of trig there again. Now, but this one now is much more likely now. This one here, here's the one, right? The ln of this square root. So what do I do with that square root? I change it to the power of half. Can I enlarge that? No, I don't know if I can. Oh yeah, okay. So the half comes down then. I haven't differentiated anything yet now. Y equals, no differentiation has taken place. A half into, now there's a 1 over the other. So we're back to this rule here. This rule here, that one, working backwards. 1 over the other with a minus in the middle. Then, so we have it set up now. Now we can differentiate. The derivative is going to be keep the half, that's the product, the multiplying factor in front, keep that as usual. 1 over that multiplied by 2x, the derivative of that. 1 over this multiplied by 1. Yes. And that 2x will go on top. That 1 goes there. There you have it there. Oh, sorry, no, that was meant to go like that. Okay. And that's a nice one there now, using the rules of logs. That would be nice if something like that came up. Okay. Because, I mean, you could, you know, they could give you a hence or otherwise, but you'll be there, you could be there all day now trying to differentiate that using, you know, just algebraic means. Very, very difficult, because it's a u over v inside, very difficult. Okay. Anyway, I think that's it. I think we've gone through everything there. And so you can look back over that at your leisure. There's a lot in that. So, and I'll have to do more of these now. A few of you were asking me for these, so I should do more of these really. And I could do another one there on, there's meant to be an E at the end of that there, IE, there you go. I'll do another one now, maybe on integration as well. Okay, so I'm gonna log off here and I'll talk to you all later.